Welcome back, guys. So let's start the show. We are on letter D, and let's start. What is D ring? So D ring collection of very faint thin rings extending from the inner edge of the C ring down nearly to the cloud top of the Saturn. This region contains a few particles that often invisible from the earth. Okay, we have discussed about the Saturn rings in detail in our previous video, so you can definitely refer to them and get some more insights of the following. Okay, next is dark dust cloud. Dark dust cloud, a large cloud, often many parsec across, which contains gas and dust in ratio of about 1012 gas atoms for every dust particle. Wow, what a ratio! Wow. Typical densities are few tens or hundreds of million of particles per cubic meter. Okay, let me just take you to the illustrations. Oh yes, here we go. So here you can see the dark dust cloud. We are not able to see what is behind this. We can see here a dark line is going in between, which is nothing but the dark dust cloud, which blocks the radiation coming from the stars, which is behind the dust. Hence it makes an opaque, it makes the radiation opaque for us. Here in the radio observation, we can see that there is matter in between in the radio. Okay, so this is not an empty space but contains dark dust particles which are not which we cannot see, and they also blocks the right radiation coming from the stars behind it. Okay, so let us refer to the text. Obstructions and emissions. At optical wavelength, the dark dust cloud known as L977 can be seen only by its observation of the background star. We can see the difference from the background star. Okay, and B, the second image, at radio wavelengths it emits strongly in the CO molecule line, which the most intense radiation coming from the dense part of the cloud. So the emission is by CO molecule, which is carbon monoxide molecule. Okay, next is a dark dust cloud. The image which shows the operant dust cloud resides only 170 parsecs away. Okay, the distance between us and the dark dust cloud, by colorful stars and nebula that are actually small illustrated parts of much bigger and innovative molecule cloud engulfing much of the region shown. So I think you get the idea what is dark dust, and it makes the observation as same difficult as well as clarified at the same time. Okay, let's get back to the definition. Next is dark energy. Dark energy, genetic name given to the unknown cosmological force field thought to be responsible for the observed acceleration of the Hubble expansion. I think you get the idea. We have discussed the dark energy, dark matter in detail in just a while. Okay, what is dark halo? Region of the galaxy beyond the visible halo where dark matter is believed to be reside. Okay, so here we go. So here we have evidence for the dark matter. So in this illustration we can see that this is the center of the galaxy. The zero represents the center of the galaxy where the black hole is present, and according to Kepler, when we are going away from the center, the density is going to decrease, but as well as the spiral effect, or you can say the velocity of the point near the center and a point which is on the edge of the disk, they will move on at different spaces, but in reality we observe that they both move with the same pace, and the density do not decrease but instead increases while going outside. So this is the evidence for the existence of dark matter. Okay, Okay, so how we can see that, how we can say that there is a dark matter. So dark matter is considered to be the force, the gravitational force which is holding up all of these massive structures. Okay, we can observe dark matter because of its gravitational force only. Okay. Okay, yes. What is dark halo? Yes, let me just take you to the dark halo as well. Okay, where's dark halo? Yes, here you go with the dark halo. Here you can see that the different regions in a galaxy. So when you go down, you can see that there is black all the way, and in the middle, or the main structure, the main spiral structure is lightened up because the star formation is constantly going on. But what about the black region near the galaxy? These are called halos, dark halos. Okay, I think you get it. Next, dark matter. We've discussed it. Dark energy, dark matter. Okay, very familiar figure for us. Dark matter particles. Wow, dark matter particles. A particle undetectable at any electromagnetic wave, but can be inferred from its gravitational influence. Only due to the gravitational influence they can be identified, and there's no evidence that we can either see it or I can feel it. Okay. Next is daughter fusion theory. Theory suggesting that the moon originated out of Earth. So let me just take you to the illustration for this. The moon is originated from Earth. So how this could be possible? So moon formation. The sequence shows a simulated collision between Earth and an object the size of Mars. The sequence proceeds from top to bottom and zoomed dramatically in the later frames. Note that how much of the interpreter metallic core become part of Earth, leaving moon composed par- partially of rock material. Okay. So here you can see that two objects, two big objects. One is considered to be the Earth, and second is considered to be uh, an object which is almost of the size of Mars. This took billions of years ago. This process was carried out billions of years ago. So when they collide, they interchange their particles, and due to the greater gravitational force of the first or the bigger one, the earth one, it sucks in all of the particles and left with small dust particles which them collapse with each other and forms combines with each other and form a small mass which we know today is moon. Okay, thank you then. So let's move to second. Next is decay decalcination. Celestial coordinate used to measure latitude above or below the celestial equator on the celestial sphere. Okay, celestial sphere, we have discussed about celestial sphere in detail in a previous video as well. So here, right aberration and declination and aberration. Okay, so this is the celestial sphere, and measuring distance up declination and down is also declination. Going up towards the pole is a declination, and moving along the equator is called acclination. Okay, this is just a very simple concept. And do you guys know why is celestial sphere used? Celestial sphere is used to keep an account of the stars around us. We assume that the stars around us, the constellation, are bound in a sphere which we call as celestial sphere, but actually they are not bounded. They are spread everywhere around the universe, but it is just the formation of pattern to understand the following concept better. Okay, to make our understanding better. Next is decoupling, event in the early universe when atoms first formed, after which photons photons could propagate freely through the space. Okay. Do we have any illustrations for this? Yes, we have an illustration. So here you can see the radiation matter decoupling. When atoms form, the universe become transparent to radiation. Thus, observation of the cosmic background radiation reveals condition in the universe around a time when the redshift was 110 and the temperature was less than 3000 Kelvin. For an explanation of how we can see a region of space 14,000 megaparsec 46 billion light years away from the universe is just 14 billion years ago. Yes, so it gives us a very clear question that how we can observe 46 million billions 46 billion light year ago image, and we say that we exist, our existence of the universe took place from 14 billion years. So how this could be possible? This is a very controversial and a very known question in the field of astronomy. So the universe is transparent here for the radiation, and no radiation from outside can go inside. It just deflects from the outside region. This is the photosphere at redshift 1100, and the universe is opaque out here. Nuclei and free electrons. Okay, I think you get the idea. Okay then. Wow. Next is deferent, a construction of a geocentric model of the solar system that was needed to explain observed planetary motion. A deferent is large circle and and circling Earth on which an eclipse move. Okay, this gives us the theory of eclipse, that the path in which the planet move around a bigger body is an eclipse. They follow an elliptic orbital. Okay. Degree, unit of angular measure. There are 360 degrees in one complete circle. Okay, you guys, I think know this very well. Next is density, a measure of compactness, of matter within an object, computed by dividing the mass of the object by its volume. Density equals to mass upon volume. Units are kilogram per centimeter cube or grams per cubic centimeter. Okay. Next is de- detached binary system where each star lies within its respective Roche lobe. We have talked about Roche limit in the concept where we discussed that how the rings of Saturn are formed. So this is what we'll call Roche lobe, where the two stars can form a system around each other without disturbing or without deforming each other. Next is a detector noise. Reading reading produced by an instrument even when it is not working anytime, produced by the electronic components within the detector itself. So these are, I think, these are the unwanted noise that we don't want in our observation. But sometimes what happen, that we are not working on an experiment, but we are getting such a radiation or some wavelengths that we don't want, and we either check the machinery that the sound produced is either coming from the universe outside us, or or only from the machine. So as we have discussed earlier about the micro cosmic background. So, in the beginning, the scientists assumed that the noise is coming from the detector itself and not from the universe. But when they cleared all the obstructions or checked their machineries again and again, but still they are getting the noise, so they confirmed that the noise is from the universe. Hence, this is a very useful phenomena, and I think, or it could be very destructive as well. Next is deuterium and neutron. Deuterium in a hydrogen, an isotope of hydrogen in which one more neutron is present. Deuterium is nothing but the nucleus of deuteron, where the deuteron is also known as heavy hydrogen, which is represented by a D. Okay, deuteron is an isotope of hydrogen. Okay, next is differential rotation. Differential rotation is very much, you guys are very much familiar with the differential rotation because of the sun, because of Jupiter, and because of all the other giants, gaseous giants. They all follow differential rotation. The tendency of the gaseous sphere, such as Jovian planets or the sun, to rotate at a different rate at the equator than at the poles, more generally a condition where the angular speed varies with the location within an object. Okay, very good. Next is differentiation. Variation in the density and composition of an body, such as Earth, with low density material on the surface and high density on the core. Differentiation. Okay, high density material are always present inside the body because of its high density, and the low density always floats over the high density. So this concept is followed all over the universe, that the cores we found are molten cores, but they are made up of what? Iron, which is highly dense and very compact, and due to the molten core we get a very strong magnetosphere which protect us from the charged particle which are arose from the solar winds. Next is differential grating. Sheet of transparent material with many close speed parallel lines ruled on it, designed to separate white light into a spectrum. Okay, this is to make a spectrum very clear to us, to in order to observe the spectra very clearly. Okay, next is diffraction limit resolution. Theoretical resolution that a telescope can have due to difference of light at the telescope's apparatus, depending upon the wavelength of radiation and diameter of the telescope mirror. So resolution of a telescope is inversely proportional to the wavelength of the radiation we are gathering, we are collecting. Okay, next is direct motion. Direct motion is nothing but prograde motion. Prograde motion is a normal motion of an orbiting object, and axial motion. This contain orbital motion or the axial motion, the rotation and revolution in a regular manner, in a normal manner. The converse of the following is retrograde motion, which is shown by the planets such as Mars, according to our situation, according to our location in the solar system. Okay, retrograde motion is shown by Mars. Okay, next is distance modulus. Difference between the appearance and the absolute magnitude of an object, equivalent to distance by the inverse square law. So do you know that why do eclipses are successful? The sun, as we know, is a very massive body, but it is covered by the moon during a ellipse. How this could be possible? This is possible because of the distance. The sun is very far away from us as compared to the moon, and their size is then accomplishable because of the following distance. Hence they are able to cover each other during their respective eclipse, whether it is solar or a lunar eclipse. Okay, this is because of a very special condition. The size of moon is just as perfect as size of sun, and the perfectness in the distance between the earth and the respective bodies is also perfect. I think the universe is programmed, because everything we observe has something useful, has some meaning in it. Okay, so we should also have some meaning for our life, some meaning for our goal, some meaning for the community and society. As young scientists, it's our duty and right to know more and to spread more. Okay, next is the diurnal motion, apparent daily motion of the star clusters, stars caused by the Earth's rotation. So Earth is in constant rotation motion, and due to this we see different in appearance daily in the appearance of star. Okay, we have changed position every day due to the position of the earth in the solar system, whether it's around the sun or on its axis. Next is DNA, deoxyribonucleic acid, the molecule that carries the genetic information and determines the characteristic of the living organism. So DNA is an integral part of our species, of our, is not only for us but for the whole life existing in the universe. DNA is the packet, DNA is the information packet which makes the same human beings or the same creature with the same genetic code in order to pass them from generation to generation. So you can just take this as a formula to make human being of the same species. DNA is just a formula, a specific formula for a specific series of creatures. Next is Doppler effect, any motion induced change in the observed wavelength or frequency of a wave. We have discussed the Doppler effect in our first video, so you can definitely check that out. Okay. Next is a double line spectroscope binary system in which spectral lines of both stars can be distinguished and seen to shift back and forth as the star orbit by another one. Because of the intensity of light is constantly changing, we could observe these kind of differences. Okay. Next is a double star system containing two stars in orbit around one another. Two stars which orbit around each other in their around their center of mass. Okay. Next is Drake equation. Why I have marked it with, highlighted it with red? Because it is very important. Expression that gives an estimate of the probability that intelligence exists, wherever in galaxy, based on the number of supposedly needed condition for intelligent life to develop. Okay, let me just take you to the formulation also. So here you go with the Drake equation. This is the great Drake equation. An early approach to this statistical problem is known as the Drake equation, which is the problem is to find the existence of other living creatures in the universe. After Frank Drake, the US astronomer who pioneered this analysis. Okay, so we are going to discuss this. Number of technological intelligent civilization now present in the universe, present in a galaxy. Okay, we are talking about galaxy equals to rate of star formation averaged out the lifetime of the galaxy into fraction of stars having planetary system. Wow, just like us, you can just consider the following data and just make a visualization of our earth and make a mark that on which criteria earth is satisfying and how this led to the formation of life, this formation of us here, okay, on the earth. Average number of hospitable planets within those planetary system. That's why we are looking for so many habitable planets such as Titan. We are looking to civilize there. We are looking for Mars. We are looking for Venus. The planets where we can hospitalize ourselves, where we can live. We are looking for those planets also, and multiplied with fraction of those life bearing planets on which in intelligence evolves just like us. Fraction of those intelligent planets that develop technological society, average time of the technological competent civilization. I think you get the clear idea about Drake equation. You can just refer to my videos about Drake equation in the coming while, because we are going to discuss this in detail, because in astronomy this is a very prominent question, that why only us, or why do we are not being able to communicate with other species. So you can refer to our videos. I have made a video correlated to this topic, hence you can get a clear idea. So let's get back to our presentation. Next is a dust grain. An interstellar dust particle roughly 10 to the power minus 7 meter in size, comparable to the wavelength of visible light. Wow. Okay, I just get a remarked that do you guys know that how micro oven is work? Micro oven, how do micro oven work? So micro oven make use of microwaves, which has a wavelength which correlates with the wavelength of the size of the particle of the food, or the food we are going to eat. We are going to make it hot. So the concept here used is the concept of resonance. Due to the same wavelength, the particle of the food resonate, hence creating energy, and the energy is radiated out as a form of heat energy, hence making the food item hot and ready to eat for us. Okay, I think you get a great insight, and get motivated, because you should be motivated because of these small concepts, because they are related to our daily lives. And I think that astronomy is the science, is the ultimate science, which we have discovered and been working from thousands of years. Okay, next is dust lane. A lane of dust obs- obstructing interstellar dust in an emission nebula or galaxy. So we have discussed earlier about dark dust. So dark dust, we have specifically discussed it with the stars, making an opaque for the radiation for the stars. But in dust lane, it makes the radiation opaque from the nebula and the galaxies as well. Okay, this is a I can say that it is another type of the dark dust, or a type of dark dust, a type of dark dust. Dust tail, the component of the comet tail that is composed of dust particle. We are going to take the discussion to the comet as well, and we have already completed the comet discussion in the previous videos. Dwarf, any star with radius comparable to or smaller than that of the sun, including the sun itself, is a dwarf. Wow, we talk about that white dwarfs, red giants. So dwarf came out from the following. White dwarf is small, but it has very much fuel and very much radiation. So it gets exhausted very quickly, and it makes an impact. It makes a great impact. It gives a very large amount of energy in a very short span of time. So that's why it gets exhausted very quickly, the white dwarfs. Okay, next is a dwarf elliptical galaxy are small as 1 kilo parsec across, containing only a few million stars. Okay, dwarf elliptic, this is a type of elliptical, is a type of galaxy. Dwarf galaxy, small galaxy containing a few million of stars. Dwarf irregular, this is also a type of galaxy, small irregular galaxy containing only few millions of stars. Dwarf planets, a planet that orbits the sun, is massive enough that its own gravitation can cause its shape to the approximate spherical, but insufficient massive to clear the other bodies from the neighborhood on its orbit. So do you guys know that Pluto is no more a planet, but is considered to be a dwarf planet because of the reason that it is not being able to clear its orbit because of its gravitational field. Hence it is not considered as a planet. The planets, just like our earth, is able to clear the obstruction, the small bodies which came in the orbital path of earth, and hence considering it to be an planet, whereas Pluto is unable to do so, hence it's considered to be a dwarf planet. Next is dynamo theory, theory that explains planetary and stellar magnetic field in terms of rotation, conducting material flowing in an or interior object. Okay, so here's a dynamo. Dynamo is nothing but a energy generating, a magnetic field generator. Magnetic field generator is a dynamo. When arch belt, yes, when arch belt is the end point of the what magnetic is, oh, sorry, when arch belt is the end point of the magnetic magnetic field of the earth. And the Mars mission launched by the ISRO is the first mission in which India has crossed the Van Allen belt. This is the path of the magnetic line. This is the magnetic line, and there are particle path around it. So this is a responsible, this is the magnetosphere of the earth and responsible for the phenomena like aurora on the poles. Netherlands is very much famous for the phenomena of auroras. When Allen belt, Earth's magnetic field resembles somewhat the field of an enormous magnet buried inside a planet high over Earth's atmosphere. The magnetosphere, light blue green area, contains two donut shaped regions, grayish area of magnetically trapped charged particles. These are called, there are the Van Allen, these are the Van Allen belt. I think you get the clear idea what is Van Allen belt. And in the core there's a magnetic dynamo, we can call it a magnetic dynamo. There is a fused core. In fused, we have a fused iron core which rotates at an enormous speed, which is response, and hence creating the magnetosphere around us and protecting from the charged particles. Okay, I think this all for this session, and we have completed D. Stay tuned for the E, and keep learning and keep exploring. Thank you.